Okay, so here is for the first sample problem out of the book. This is sample problem 2.4, and we have the ship, and they're removing this 3,500-pound automobile from the ship, and it's being supported. You can see this dude is pulling on that cable, and it's resulting in a 2-degree motion here, and it's the cable makes a 30-degree angle with horizontal, and it's a 3,500-pound vehicle. So the first thing that we want to do here is get the FBD drawn. So the FBD is just going to be of this piece right there, and we want to declare X and Y. And maybe I will use different colors as part of this. So we have a force that's coming this way, and we have a weight coming down, and then we have a force coming this way. And sometimes I like to use green for geometry types of things right in here, right? So we have that angle and that angle. And this angle is 30 degrees. And this angle is 2 degrees. And then I want to label everything. Let's label it with red. And so this is going to be, I'm going to call this F. Sometimes I call it weight. Sometimes I'll do that. And we can just label with the values onto here. All right, so that's 3,500 pounds. And I like to give things labels. Like this is A right here. So I'm gonna call this cable AC, right? And I go alphabetical order too. So this cable right here is going to be FAB. And we want to know the tension in the rope. Right, it says the rope. Okay, so I guess when they were calling it cables, like they're saying that this right here is. I didn't mean to draw that. Let's see, that's a cable, and so is maybe the thing that's coming down from there. But okay, so this is the rope. This is the thing we want to try to find out. But we don't know FAB. But we're going to see once we get the thing started that we're going to be able to find out what it is. So we say the sum of the forces in the x direction equals 0. Declare what positive is as part of this. This is the complete treatment of this, right? You're leaving things out. Don't skip steps. So we take a look at the x direction. Let's start out with the FAB. We notice it's going to be negative FAB, and it's going to be the sine. And I'll go ahead and put values in instead of just going with symbols. And then in the x direction for FAC, we say plus FAC times the cosine of 30 degrees equals 0. Now, we can employ a strategy here. We have two unknowns, FAB and FAC. But we're going to want to find FAC. We were only asked for FAC. So let's solve for FAB, because we know that we're eventually going to want to get rid of FAB. Right? So we take that and we look at FAC, and we can see that would be cosine of 30 degrees divided by the sine of 2 degrees. And if you put that into your calculator, you find that you get 24.81 FAC. And now is a really good time to take just a pause and think about what that means. What that says is that the cable, the tension in that cable AB is almost 25 times what that tension of that rope is being pulled. That's a real understanding piece of information. And now we take the sum of the forces in the y direction, because we can't go any further right up there. And that's actually a solution strategy we'll often employ. If you get stuck on one thing and you can't solve it, then move on to something else and put a pin into the other thing. Here I notice, and I put a circle 1 around there, because that might be an equation I'm going to want to use later, right? So I take the sum of the forces in the y direction, and first again, I take a look at FAB, but now it is in the vertical direction, which ends up being the cosine of 2 degrees. And we also know it was positive, right, because it was positive up. And then we have a negative FAC, but this time it's going to be sine of 30 degrees because it's the component opposite from that angle. And then lastly, we have a negative 3,500. So that's our second equation. And we want to definitely label things, or we want to give like a little narrative to communicate. We want to combine 1 and 2, right? So I do that by replacing. I got to double check and see what I did. I think I got the right answer. Let me see. I double check something here. I think my number is going to be slightly off, so let me fix this as I come through. Whoops, what happened here? Stop. Cut it out. Come on, be it back. No. All right. Come on. I'm not changing this video, even though I just found a mistake in my thing. All right. So I replace, I take that 24.81 FAC, and I forgot to multiply it by my cosine of 2 degrees. It's probably not going to make much of a difference because cosine of 2 degrees is going to be pretty close to 1. But we could check that here in a second. And then FAC, and that's the sine of 30 degrees minus 3,500 equals 0. All right, so let me double check my thing here. I take my 24.81, and I take 2, and yes, the cosine of 2 is 0.9994, right? So it doesn't change it a whole lot. And then, but I also have negative sine of 30. So I take the sine of 30, and now that's going to be subtracted from there. That 3,500 goes on the other side. So I'm dividing it out, and what I end up finding is that FAC is equal to 144.1 pounds. And that's my answer. So I need to fix this right here. Write this one, the cosine of 2 degrees, and come up with this 144.1. Now, if you take a look at the book solution to this sample problem, they will do things with triangles and law of sines. But I've decided that I think for our class, we're going to go with the free body diagram because this is the foundation of almost all solid mechanics right here. And playing with triangles and so forth, it's an interesting and an effective way, but this is the standard way. So let's see, we'll end the show and see how long this video was. 8 minutes, good enough.